we've discussed logarithms in definition, but there's some certain properties that follow directly from the definition of a logarithm that we are going to be helpful to apply. Now, remember we talked about that the natural log of 1 is equal to 0, so it's always good to keep in mind. The second one is that the product of two numbers, the natural log of a product can be split into the addition of logs. Now that one may be a little more difficult to figure out why that's true, but that is the definition of that. Now, in this one, what we have is if those numbers are divided, we can split those into a subtraction. And finally, if I have the log of a number to a power, I can move that power out front and have the natural log of just the number itself. Now that's true if n is rational. If it's irrational, you have to be a little more careful. And so anyway, these are your four major properties, and we're going to use those to apply to expressions, because if we're going to use calculus on these expressions, it's important to be able to break them up or put them together as is convenient. The first one is natural log of x over 2. So if I look at that, I go, okay, that looks like I need to apply property 3. So I'm going to say that's natural log x minus natural log 2. And that's all I need to say. The second one is natural log of 5 over kx. So I'm going to need to apply property 3. So that's natural log 5 minus natural log kx. But then I can say, oh, okay, I have property 2. Those are two things multiplied together. So I can say natural log 5 minus natural log k plus natural log x. At which point I should probably just say natural log of 5 minus natural log of k minus natural log of x. So this is a really good example of a shorthand you can do. What you find is that anything in the numerator is positive, anything in the denominator gets a negative added in front of it. So if you start here, you say, okay, that's natural log. Anything in the numerator is split up into its own log with a positive. Anything in the denominator is split up into with negatives in front. Now this can become more complicated if there's like a negative out front here, but if it's just a log like this, the general behavior applies. For the next one, we're going to apply multiple rules. So I've got a square root. So what I want to do here is I want to say, instead of a square root, I want to say that's the natural log of 13 minus x over x plus 4 to the 1/2 power. So I want to convert that square root to a 1/2 power. That way I can use property 4 to get something that looks like that. And then I can apply property 3 to arrive at that. Now, it's important to remember that that 1/2 has to distribute to all of those, because what you would do is you would split up the natural log into that, the way that you would do it here, but then that 1/2 gets distributed to each term. So don't forget that. This is a very common mistake, is to apply the 1/2 here and forget that it goes there. So do yourself a favor, don't make that mistake. Now finally, we want to go the other way. We want to say, all right, I've got this nasty bad boy, how can I bring it together? So this is often very useful in calculus because we're going to use this for differentiation rules. But this can also be useful because being able to combine them in a single quantity might allow you to cancel some terms. In this particular case, it doesn't, but it can allow for that. And when that happens, you can then condense it, cancel terms, and maybe break it back out, or maybe not, depending on what you're trying to do. So we're going to work our way sort of inside out. Now, to combine all these, what I've got to do is I've got to make sure that they all have the same coefficient in front, and they don't. This doesn't have this has a 5 in front. So what I have to do is I have to rewrite that as natural log of x plus 1 to the 5th. I kind of write it like that to make it less ambiguous. Plus natural log of x minus the natural log of x squared minus 2. Okay, so now they all have the same coefficient in front. That's helpful because then we can apply the inverse of this rule. Now remember when I said everything that's positive goes in the numerator, everything that's negative goes in the denominator. We can use that rule here to say, okay, that's 1/3 natural log, all right, that's x plus 1 to the 5th, and then there's an x. And so those are positive, they go in the numerator. That's negative, so it goes in the denominator. Like that, okay? And so we're almost done. We have this, but we have this 1/3 here. So we want to move that up. But 1/3 power is the same thing as saying a cube root. So you have the natural log of the cube root of x plus 1 to the 5th times x, all divided by x squared minus 2, again, inside of that cube root. And that's how you combine those things. And being able to do that is being comfortable with those manipulations are really going to help you not trip up on the algebra part and focus only on the calculus.